Here's another example of using the comparison test to show if an improper integral converges or not. This is the one that we're dealing with, and we are going to see if we can compare this with this or that. Well, take a look right here. How did we get this? We just ignore the top and of course put a 1, so we have 1 over x squared. How did we get that? Well, the truth is, you look at the highest power of the x on the top and also the highest power of x on the bottom. So let me write that down for you guys real quick. To end up with the 1 over square root of x, in fact, we just look at this portion, and that's actually instead of the square root, right? So we also have to include that, and then also that. So we look at the integral from 1 to infinity of the square root of x to the third power over x squared, and work that out. This is the same as saying integral from 1 to infinity. This is x to the 3 over 2 power over x squared. And then if you just work out your exponent, you will see that this right here is just x to the negative 1/2, which is the same as 1 over square root of x. So that's how we came up with these two improper integrals. Alright, but let's see if we can actually use this to compare with or not. First off, this right here is just a p integral. P is equal to 2, which is greater than 1. Therefore, we know this improper integral converges. And you have to remember the kind of inequality that we wish to show when we have a convergent integral that we know. Alright, let's go ahead and do the check. Let's go ahead and put that down, which is the integral going from 1 to infinity of square root of x to the third power plus 2 over x squared. Because once again we have a convergent integral, so we wish to show that this right here is smaller than or equal to, but we don't know yet, the convergent integral that we know, which is the integral going from 1 to infinity of 1 over x squared dx. And again, this and that, everything is positive, so we can just indicate that. So that way you can see we won't end up with a negative infinity, that kind of thing. Okay, so once again, this inequality is crucial. I just have to emphasize that it's not an innocent mistake when you put down a wrong inequality. It's not an innocent mistake, it's a crucial mistake. But anyway, let's compare the functions inside, and that is square root of x to the third power plus 2 over x squared. Is this less than or equal to 1 over x squared for x greater than or equal to 1? Well, you can see that the bottoms are the same. This right here is definitely bigger than 1. Therefore, this is definitely false. Oh no, if this is false, what can we say about that? We cannot use this to do the comparison, right? So cannot draw conclusion with this improper integral. So inconclusive with this improper integral. Okay, now no problem. Let's take a look at this one. This is a very different improper integral because you see that this is actually just the integral going from 1 to infinity of 1 over x to the 1/2. So we can see that p is equal to 1/2, which is less than or equal to 1. Therefore, this right here diverges. So now, this is the check that we are going to do first. Let's go ahead and write that down. Well, let's put down the one that we have, which is the integral going from 1 to infinity, and we have the square root of x to the third power plus 2 over x squared. And because we have a divergent integral this time, so we hope to show that this right here is bigger than or equal to the divergent integral that we know, which is the integral going from 1 to infinity, 1 over square root of x. Let's put that down right here. Yeah. But we don't know if this is true yet. Let's put down a question mark. Once again, this right here actually diverges to past infinity. So if we can show this right here is bigger than or equal to that, that means we can argue that this right here has to be a bigger infinity. Therefore, this right here also diverges. So we really want this inequality right here. And everything is positive, so let's just indicate that, right? Because there's no subtraction and the x is going from 1 to infinity, so yeah. Alright, now let's check the function, namely square root of x to the third power plus 2 over x squared. Is this bigger than or equal to 1 over square root of x? And we just care about when x is greater than or equal to 1. And this is not clear, right? Unlike the one that we did, but it's okay. Let's just cross multiply. This times that, I'm going to write it as square root of x times square root of x to the third power plus 2. And then we'll put this right here. And because everything's positive, so we maintain the inequality, but we don't know yet. This times that is just x squared. Well, is this true? Check this out. If I multiply the x inside, we get square root of x to the fourth power, and then x times that is just plus 2x. And we can do this no problem because x is greater than or equal to 1, so everything inside is positive, so no big deal for that. And then, is this greater than or equal to x squared? Well, this right here, it's already x squared, and we are adding more stuff after that. So for sure, this right here is bigger than that. Therefore, this is true. So much better, right? Because we know if we end up with a true inequality, we can say the original improper integral also diverges. So let's go ahead and just write down our conclusion. Alright, the conclusion is the integral that we were dealing with, the integral going from 1 to infinity, square root x to the third power plus 2 over x squared. This right here also diverges. Why? Well, let's go ahead and say by CT. I ran out of space, so comparison test. This right here is the conclusion for that improper integral. So hopefully this right here helps. And check out my other videos because I'll show you guys how to write a comparison test proof with the 3 steps.